part draws on this recap right here. Okay, so the key is x is going to be less than a units from 0. So your solution is going to look like this. So you're going to have negative a and positive a again, but your solution is going to encompass all the things in the middle. Okay, so the middle area, the middle stuff. Okay, so really this applies to this because it's closed circles. If it was this, it would be using open circles instead, okay? Don't forget that. When you're talking about inequalities greater than, equal to, or just greater than, when you have less than or greater than, you use open circles because they're not part of the solution. But if you have less than or equal to or greater than or equal to, then you use closed circles. Okay, so the key is, again, your x value is going to be less than a units from 0. And then, number 3, the absolute value of x is greater than a, or the absolute value of x is greater than or equal to a. So this means the distance from x to 0 is greater than a units, okay? So what we're going to do, well, that means your solution is going to look like this. You have negative a, 0, and positive a, but your solution is going to be going away from each other, right? They're going away from each other. They don't connect, okay? Because that means your absolute value is either going to be so big compared to a in the negative direction, which is still a big distance, not negative, or it's going to be a big distance in the positive direction away from a, right? Because we have to have something that is greater than a in distance from 0, okay? And of course, like I mentioned up here, you would use closed circles if you have equals, like greater than or equal to. But if you have just the greater than part, then again, you're just going to use an open circle. So that is a key concept to remember when you're doing graphing like this. All right, so we've got one small thing to talk about before we wrap up, and it's about a real-world concept called tolerance. And maybe you've heard about it, maybe you haven't, but in any case, it does have to do with absolute value inequalities. So, tolerance, I'm going to write it up here so you can keep it in your mind while I'm talking about it. Tolerance, okay, so what is tolerance, right? What is it? What is it? Okay, so tolerance is, it's something we can model with absolute value inequalities. And what it is, it's, okay, so it's when you take a manufactured item, you take the actual measurements, and you take the target measurements, the goal measurements, the ideal measurements, versus the actual, right? So you're taking actual measurements versus your ideal measurements, and you take their difference. You figure out what is the difference between the actual measurements and the measurements that we want. So the measurements we get and the measurements we want. The actual and the target, or the ideal, or the goal measurements, whatever you want to call it. You take those two kinds of measurements, you take their difference, and tolerance is half of the difference of the maximum and minimum acceptable values, okay? So when you take actual and target measurements and you take their difference, that's basically half the difference of the max and minimum acceptable values. So we'll check this out a little clearer. I think a word problem would better clarify this. Okay, so let's say we're talking about car racing. So in car racing, a car has to reach certain dimensions to enter a race. So let's say the greatest allowed height for this car, greatest or max allowed height, the greatest or max height is 53 inches, okay? And the least or minimum height is 51 inches, okay? And our desired or target height, okay, is 52 inches, okay? So, what do we do to determine the tolerance? Well, or use the inequality. Well, first what we're going to do is first find tolerance. So tolerance, we're going to take the difference between the max and the minimum. 53 minus 51, we're going to divide that in 2 because we're finding, remember, half the difference of these minimum and maximum acceptable values. So we have 2 divided by 2, which is 1, okay? And what this 1 stands for is, this is what we want the height to differ by. So like, if we want our actual height to deviate or differ from the ideal only by 1. So like, remember, our target is 52 inches. So we only want the real height to differ from 52 inches by 1 inch in either direction, okay? So this basically means we only want it to deviate by 1 inch on either side. Okay, so our next step is we're going to consider h as the race car height. So race car height, okay? So we can write this as an inequality. -1 is less than or equal to h minus 52 is less than or equal to 1. So -1 is less than or equal to h minus 52 is less than or equal to 1. So like I was saying, this basically means you plug in your height, it has to differ from 52 by 1, by 1 in terms of distance. And that's why it's sandwiched between -1 and 1, because it's in either of these directions, basically. So that's our inequality. And our final step is to compact this, so we can rewrite it as the absolute value of h minus 52 must be less than or equal to 1. So this distance, so the distance of this must be less than or equal to 1, because that is our tolerance, right? We don't want it to be different from the target height of 52 inches by any more than 1 inch, okay? So this is our inequality. The absolute value of h minus 52 is less than or equal to 1. And that is a good example, I think, of how you can use absolute value in real life. Because I know with math, especially algebra sometimes, it sometimes feels like you're learning all these concepts that are kind of in a field of their own and don't really have any application to the real world. But this kind of stuff proves otherwise. I tell you, word problems can be challenging, especially depending on what kind of math course you're taking. But if you can master them, then that helps you master an application in the real world, because that's the key of it, real world, okay? So this wraps up the videos, finally, on absolute value equations. In the next set of videos that I'll be probably making like in the near future, we're going to start a new chapter, a new unit on relations and functions. So it's going to be fun. So until then, Maya out.